obviously, all of these new technologies and their potential application in humans raise ethical issues. And therefore, we decided we will close this session with a discussion of ethical considerations on crossing the germline. And there's obviously nobody better suited to do this than Arthur Caplan, who now over the last few years has been here in New York City at NYU. Arthur, it's a pleasure having you.
Thank you.
This stool is for you.
Oh, good. Very good. Thank you. So thank you for having me. These presentations this morning were really fascinating, and I was very, very interested in the Chimera work and just trying to imagine how the new Congress will respond to that. But that will prove interesting. The achievement of bioethics, one of the great things people say, well, what do you get done? We have produced these disclosure slides, which you're looking at in front of all the talk. That's mine. It just says that I've worked with Janssen to develop a committee that helps them allocate unapproved medicines, and a similar thing with AbbVie. We're very proud of these slides in bioethics. No one else seems to care. So, germline engineering. The issue basically is, for all of the work we've heard about today, including all the mitochondrial, whether it's a spindle or nuclear transplant, can we do germline engineering? Will it be permitted? And as I think some of you know, it is considered a bright line by many that ought not ever be crossed, that we should not be altering the germline. You can do whatever you want with somatic cells. You can CRISPR even stem cells inside a person's body to do various things, but you can't cross the line of germline when it is going to be something inherited or passed on to future generations of humans. There are those who argue a little bit that it, in fact, ought not be done in certain types of animals, but we'll put that for another day. So I'm going to focus on the human issue and this bright line question. And I won't keep you in suspense. I think the germline engineering prohibition, ban, or bright line should not hold. I don't agree with it. I think that it should be crossed, but it's probably going to have to be something done on a case-by-case basis. But I don't see any overwhelming argument that says never. But one of the things I'm going to present to you is a little history. I'm old enough now so that I remember how this argument got going, and I think many of you in the room may be of the opinion that the argument about don't do germline engineering came from outside the medical community. But it didn't. It actually came from inside the scientific community and then was picked up on by ethicists, public citizens concerned about where genetic engineering might be going. So this is the policy that the NIH has here right now. No money for any use of gene editing technologies in human embryos. The concept of altering the human germline in embryos for clinical purposes has been debated over many years, in fact, decades, from many different perspectives, and has been viewed almost universally as a line that should not be crossed. So that's the germline, bright line prohibition argument. Advances in technology are giving us elegant new ways of carrying out genome editing. We've heard about some of the latest ones this morning. But the strong arguments against engaging in this activity are still there. He means ethical arguments, Francis Collins. These include the serious and unquantifiable safety issues, ethical issues presented by altering the germline in a way that affects the next generation that can't consent, and a lack of compelling medical applications. So that was in 2015 in April. That led to a ban. It's led to a fair number of other funders saying no to germline. But notice this is a scientific pronouncement about germline, not coming from outside. Let's go back in history, distant history, all the way back to the late 70s. And I'm going to tell you the person who actually promulgated the argument about do not cross into germline engineering. It was Jim Watson. It wasn't an ethicist. It wasn't some, as Jim says here, left-wing nut or environmental kook. But based on the early recombinant DNA work, he knew that they were getting tremendous criticism from critics, some within the scientific community, few, but many outside it, who basically were saying we ought not do any type of recombinant DNA work. And this is his quote from People magazine, one of the non-peer-reviewed outlets that he sometimes spoke in. And he said, ever since we achieved a breakthrough in the area of recombinant DNA in 1973, left-wing nuts and environmental kooks have been screaming that we will create some kind of Frankenstein bug or Andromeda strain that will destroy us all. Now, Watson wanted to see recombinant DNA work proceed. That was his political goal, was to move things forward. He is not personally at all opposed to germline engineering. But he and many others, this is just a quote from 1998, basically decided to cut a deal with the public and with the world. And what they did was they said, let us do recombinant DNA work in microbes, let us do somatic cell engineering, and we promise you we won't do germline. And this is him saying partly the germline bright line was in order to get somatic therapy going, so it was said we're not doing germline. That's bad. The prohibition came from within the scientific community. It isn't something that came externally. It was, if you will, political. It was a bargain chip. If you let us go this far, we promise never to go over there. So the interesting fact about the history is that some of the objections and concerns were set by public statements by leading scientists, and I have some others rattling around here. This is Eric Lander. Back in 2000, I would have a ban in place on germline, not because I think we should never cross it, but I'd like somebody to have to rebut the presumption to repeal a ban when they thought it was time to try something like that. So this is major caution. But again, I want to point out, it's coming out of the scientific community. It's not that the public sort of was Svengali-like led over by critics who didn't know the science very well to say, oh, there must be something wrong with germline. This is generated internally within the scientific community, and I'm going to tell you, pure politics. This is Steve Pinker, who's not a geneticist, but a prominent scientific figure up at Harvard, MIT. The principal harm of germline editing is the risk of producing a sick or deformed child. Frankly, I suspect this risk will always be unacceptable, so most of the discussion about doing germline is moot. That's kind of funny. We ought to bring him to this conference. But that was, a year ago that he was making this kind of pronouncement. This is David Baltimore. We worry about people making changes without the knowledge of what those changes mean in terms of the overall genome. I personally think we're just not smart enough. Well, that's sad. And won't be for a long time, although it's not clear where we're going to get smarter per se, but to feel comfortable about the consequences of changing heredity, even in a single individual. So that comes from last year. So lest you think that this is just a fight between an ignorant public or fearful critics who don't like genetics, this whole debate has been triggered, in my view, by internal cautions issued by mainstream scientific leaders who have tried to let genetic engineering advance by, if you will, selling out the germline. And I think it's been bad politics. I mean, I think this is culpable. It's not the proper position, and it was a bargaining chip and remains a bargaining chip even to recent times. It doesn't make any sense. So my first point is reservations about germline engineering, whether it's funding or what sort of oversight it demands, or whether it's time to proceed, or whether we should finally have somebody get to this meeting and arrest everybody, is fueled by a political trade-off that was made some time ago. The second major event that occurred that really plays a role in germline here is something I'm going to ask you to answer. Jim Watson said in 1998, remember, he wanted germline engineering to happen. He just was, he thought it was too frightening to others or too likely to trigger concerns. when he drew his line, but he said some people are going to have some guts and try germline therapy without completely knowing that it's going to work. Okay. And that was in a speech out at a California university. And then by 2003, after 1998, he said, a failed germline experiment would be an unthinkable catastrophe. A human being born flawed, perhaps unimaginably so, owing to our manipulation of his or her genes. The consequences would be tragic. Not only would the affected family suffer, but all of humankind would lose because science would be set back. We can't afford, he's saying in 2003, a failure when in 1998 he said we ought to have some guts and somebody should try to pioneer and move things forward. Anybody want to tell me what changed in between 1998 and 2003? Something very big happened. Jesse Gelsinger died in a gene therapy experiment at the University of Pennsylvania. That's what happened that changed Watson's tune. It's what happened that changed the genetic community's tune about trying to use gene engineering both to repair diseases and even more difficult to imagine, to try to do germline engineering to either repair diseases or, as we heard, create tissues or cells that might someday be usefully applied in other animals or in us. When Gelsinger died, the entire field of gene therapy was set back at least a decade. I had arrived at the University of Pennsylvania about 9 months before this death occurred. I knew about what was going on in this experiment. There are all kinds of public accounts about what happened, most of which I think are not accurate, and I haven't really talked about them publicly because all the time I was at Penn I didn't feel like I could because I had a sort of vested interest. But whatever the various issues were that led to the death of Jesse Gelsinger, this became the warning Icarus story. It became a moral lesson that has also interfered with human germline engineering because it became the story of the warning of Icarus. Do not be hubristic, do not fly too high, do not go too fast. If you do and you fail, you will set the field back enormously. And it did. This is not a hypothetical, it's real. The Gelsinger death really caused tremendous turmoil in the gene therapy field. And remember, it's a single death in a human experiment. When I think back to the days when I first got into bioethics and people like Tom Starzl and Shumway and John Nigerian were pioneering organ transplant, I think for Starzl's liver transplant operations, something like the first 30 subjects died. This is one death. We are now in a much more risk-averse and highly litigious environment, very different from even what things were like in the 70s. So that death is the second reason that germline engineering has got this bright line and a restriction. It's for fear that the outcome, one bad outcome, would really set germline engineering efforts back tremendously. So again, just to repeat, initial objections did not come from outside critics, they came from inside to preempt objections to all genetic engineering, say no to the germline. When people now say we want to try germline, there is a certain kind of hypocrisy that critics are aware of, saying, well, I thought you told us you were never going to do that. How can we trust you now? Because you told us before no, and now you're saying yes. Why the shift? And then this lesson that I keep referring to, the Gelsinger death. If you get this outcome in today's climate of risk aversion, less willingness to accept bad outcomes, then you're going to destroy germline engineering. So we better be 100% sure before we engage in human application or try to do clinical things with germline alterations. Now, there are certainly critics today out there who are saying, look, moving toward germline interventions, this is just one of many, in view of the high risks and unresolved ethical issues, nobody would argue for attempting germline modification that involves initiating a pregnancy. That's from May of this year. So there are plenty of people out there who probably need a ticket to the conference. And there is this deeper fear, which wasn't one of Jim Watson's fears, because if you follow Watson, he's always been something of a eugenicist, actually. But the fear that germline engineering is a path toward a dystopia of super people and designer babies for those who could afford it, that is another type of objection, a more external one to the field. But that's the third, it's the slippery slope problem. So let me summarize what I think these arguments are. Then I just want to compare them to current work in mitochondrial alteration, the sort of thing we've heard about in the session, and then come back and see whether it passes muster against these objections, because I think it does. And I think the arguments that have been raised are not sufficient to keep that ban in place on funding. They're certainly sufficient to keep close oversight on different experiments and to decide when, in fact, it's reasonable to try and proceed. But that is not the same as a ban or a bright line that ought not be crossed. I don't think there's a bright line that ought not be crossed. And I think it's time, actually, to engage the arguments fully. So the first one is safety. Have we done the animal work? How many of you are aware of this guy who's running around saying that he wants to do a human head transplant? Have you heard this guy? He's actually...
China.
Yeah, maybe. So he's actually holding a press conference today, right now, against this meeting in London. And he's announcing a new surgical scalpel that he says can make such a clean cut in the spinal cord that it will be possible to basically join the donor spinal cord back to the recipients without difficulty. The reason I mention this guy is he is an example of why we have all kinds of problems with the public with respect to pioneering or innovative science. Does he have an animal model? Well, Sergio, I guess is his first name. When Sergio talks, he tells us that, yes, there are animal models. The Russians attempted dog head transplants in 1906. By the way, he fails to point out that the dogs died. And there were a couple of monkey experiments at Case Western in the 60s. A guy named Robert White. Well, that is not an adequate basis for animal safety demonstration. If we're going to move forward, as you'll see me say in a minute, I think we have to do much better in the animal work, and I think we're trying to do much better in the animal work. But when you have guys out there publicly saying it's time for head transplants, because there were experiments in 1906 and 1960, that's not the way to build public confidence, and that guy needs some strong upbraiding for what he's doing in terms of what the public believes adequate safety work is. Gelsinger, sure, that is a lesson that has to be taken seriously. What would happen if there's failure? And remember the other arguments that I presented to you. One is, well, we shouldn't do germline because the people who are most strongly impacted, the offspring, can't consent. Without them being able to consent to something going wrong, to having burden imposed by changes, then it would be unethical to do it. You can't do experiments on people who can't give their permission. It's said that we're too ignorant of all the complexities, although I was pleased to see that when we were talking about the chimera model, we quickly decided that there's plenty of complexities and we ought to resolve them before moving forward. The slippery slope to eugenics argument, and then one other one that you heard me mention, it'll only be the haves and the rich who will be able to avail themselves of this perfect baby, designer baby future, so that is inherently unjust, and that ought not be pursued. So those are the fallout arguments from both what internal science created in terms of objections, the failure of Gelsinger, and then concerns about eugenics. They all fall roughly into these types of objections. So we have now the mitochondrial work. We've been hearing about it all morning. One nation, Britain, voted in favor of allowing it in their parliament. And I think that is the path that the rest of the world, by the way, should be following. I'm not going to babble on about why to do this other than to say that, the list of diseases that one could treat is fairly long and complicated, and I understand that there are a lot of mitochondrial genes and a lot of things that have to be fixed that are different, and maybe we'll have precision enough CRISPR techniques to go after them, or maybe combinations of these transplant and engineer type things will help. But the point is, there are plenty of diseases out there that look amenable to, let's say, this type of germline engineering change. And by the way, I'm not unaware that some people would say that mitochondrial DNA work is not germline, but I'm going to put that on the side because most governments view anything that's hereditary as germline, putting aside whether the mitochondria is or isn't in itself a germline engineering change. The ultimate test, in my view, for proving whether any novel IVF-related technique is going to work is through humans, and that involves accepting that there will be risks. So one lesson that we need to be thinking about is in public presentations, in testimony, in talking in your community and talking to others, I think it's important to present the notion of, well, what would we do if there was harm? What would we do if a child was born with a disability or some unexpected consequence? Right now, what the American policy is, do you know what it is? You will sue. That is what the policy is. You will file a lawsuit, which, again, doesn't engender public support because you might lose the lawsuit. And certainly in, legal proceedings, things get adversarial. They're not in pursuit of truth, they're in pursuit of winning. We need to have a safety net program of some type of insurance, compensation for anybody who might be injured in such experiments. It's a pretty simple answer. You might have to go to a special master or a court to get the claim resolved, but telling people to sue if there's a bad outcome, which is what happened, by the way, in Gelsinger. That's why it became so notorious. It turned into a huge, nasty lawsuit with all kinds of allegations flying about conflict of interest, which led to the slide I showed you at the beginning, and many charges about ignoring signals of danger in animal work, and on it went. None of which I think actually turned out to be valid, but it didn't matter because they made it in the press every day, and they made it in the courtroom, and government officials responded to that. So if we don't have a method for responding to bad outcomes, if we don't have some system to compensate or make whole or support anything that went wrong, then we are setting ourselves up for a Gelsinger-like problem. So let me just end with a review of the argument. Safety. Well, I think in this area of mitochondrial work, lots of animal studies going on. I was fascinated by the talks we heard this morning. People have many, many animal models in the works. I think that has to be emphasized. This is not head transplant. This is not something where we're just saying, oh, let's tweak an embryo and help somebody remove a disease or maybe regain fertility by manipulating their gametes or an embryo. We can't be hubristic. We have to acknowledge that something could go wrong. And then the question becomes, what will we push for as a field to make sure that people have a safety net? And I think that is very important for the public and potential subjects to understand. What will happen? I wouldn't want to be stuck having had an experiment done on me trying to reclaim insurance coverage for a child that was born with a deformity because the insurance company is going to tell me to go jump in a lake. It's experimental and they won't pay anything there. So what is the safety net? But if we have it, those arguments I think are handled. Lack of consent by those impacted is a silly argument. We do research all the time on people who can't consent. We have surrogates. Children can't consent. Comatose people can't consent. I wrote rules personally for research in emergency situations in the ER where somebody comes in with an overdose. We don't know how to treat them and we want to try some new thing. That's where the IRB makes a decision about whether it's worthwhile, and in the case of reproduction, we're going to have parents. But we have surrogate consent, and we have committees established that handle situations where individuals themselves cannot consent. It's all over the place. It's a ridiculous argument. We're too ignorant of the complexities. Well, that I would agree with, but as we begin to learn more, it becomes time to try, and I think we're edging up in some areas of the mitochondrial work to the point where it's time for human efforts to establish what is known or not known. Slippery slope to eugenics? Well, that's possible, but it depends on what you're doing. So I don't think any of the mitochondrial work is going to produce super babies. If it produced a baby, that might be nice, but whether it's a super baby or some kind of otherwise designer infant, these techniques are not going there. Now, we could have techniques that do go there, but then we could review them and decide whether we want to go there or not. But to lump it all together and say, if we allowed, mitochondrial engineering, transplants into eggs or embryos, then tomorrow morning someone's going to use the same technique to make a super baby? What do one have to do with the other? It's simply a non sequitur. And lastly, advantaging the rich. Well, it would be nice if we could come up with ways to help the poor sometimes avail themselves of novel reproductive technology. And that is a political fight. This field should be engaged in that fight and trying to gain access for those who can't pay. Infertility treatment over the years has not concerned itself, in my view, enough with access for the poor. They just haven't. It's been a business, and too often for people who have the cash. So if we want to move forward and handle the advantaging argument, there is some duty to try and figure out how much do we do for free, or what sorts of things can we do to pressure companies to cover or ally with patient advocacy groups to make sure that there's some ability to get these things paid for. But I'll end on a real politic note. In the age of, we're not too far from Trump Tower, so I can end on this note. There's never been a medical advance that didn't advance because the poor couldn't get it. It's not going to stop anything. It never has. If you looked at anybody's neonatal unit in rich countries and then saw kids dying of dehydration in poor countries, no one's closing the neonatal ICU in the rich country. So we rescue babies that would be written off in many nations, but it does not stop us from enjoying benefits that the poor and the have-nots cannot access. That is not an argument that's ever going to stop the advance of the technology. Do I think there's an obligation to try and mitigate and buffer the difference? Yes. Do I think the people in reproductive medicine could do better? Absolutely. But it is not going to be an in-principle reason why something doesn't advance. It never has been. So if you take those arguments off the table, I think the time has come to rethink the bright line and the prohibition that scientists imposed decades ago. Thank you.